Alright, more than halfway done here. We're on page 6. This is probably the longest page in terms of how long it should take people to do. Start up top with factoring. By now, if you don't know factoring, this is going to be trouble, but it's the factors of this and the factors of that. Factors of 5 are just 5 and 1, so I put those there. Factors of 10 are 1 and 10 and 2 and 5, and it's a guess and check thing if you don't recall. This and this should add together to give me 23x. So if I put 2 here and 5 here, actually I'll get 25 and 2, which will give me that, so that works out. If I did it the other way around, I'd get 5 and 10, that's not going to give me 23. Here, if I have 2x and 25x, to get a positive 23, the 25 should be positive and the 2 negative. So I'll make the 2 negative and the 25 positive, and there I am, all set. Okay, this is a GCF type problem. I have to factor an x out of both of these first, and I'm left with that, and then that should trigger difference of squares, x plus 9, x minus 9. You should see that over and over by now. This problem here is just an x and an x. There's a lot more here than are actually on the exam. In fact, I think there's only 5 factor problems, maybe 6. X and x, the factors of 54 are 1 and 54, 2 and 27. I gotta think of something that multiplies to give me 54, but adds to give me 3, which is 9 times 6, as long as the 9 is positive and the 6 is negative. This is a difference of squares just like that, except for it's 4x plus 5 and 4x minus 5. If I can square root both of these, then it's a difference of squares, just like I can square root both of those and get x plus 7, x minus 7. Doesn't matter which one's positive and which one's negative, it does not. I'm going to GCF this one, so we GCF 40 and 44. A 4 I can take out all of these, and an x squared I can take out all of these, and when I do that I'm left with x squared plus 8x plus 12. 4x squared, I can factor that further, and I'm always going to want you, it says the word completely here for a reason, 2x plus 6 and x plus 2. That's the answer. Go through and circle these. This is that AB rule. If you don't remember, it was AB, A squared, AB, and B squared. I would suggest that's on your cheat sheet as well. And it was same, opposite, plus. So the cube root of x is x cubed is x, the cube root of 64 is 4. A squared is x squared, AB is multiply those together, B squared is 4 squared, which is 16, and it's same, opposite, plus. Done. Same thing over here. Here we've got the cube root of 8x cubed is 2x, and the cube root of 125 is 5. Remember, you could do that as 125 to the 1 divided by 3 power, as long as you put 1/3 power in parentheses. Now I got to square this whole thing, and 2x squared means 2x times 2x, which is 4x squared. That's how I get that term there. AB means times those together to get 10x, and b squared is 25, and I go same, opposite, plus. Done. Okay. On to some simplified problems. We're always going to break these up into something we can and something we cannot take the square root of, and what a lot of people want to do right away is make this 4 and 8, and that's right, but if I go 4 and 8, I can square root that to get 2, I can square root that, but I can break that into 4 and 2 and square root that and square root that and get, it's just craziness. If you can find the biggest one, which is 16, of course I got a -1 in there. Hopefully you remember the square root of 16 is 4. Hopefully you remember the square root of -1 is I. Maybe we should write that. Square root of -1 is I. Circle that. And the square root of 2 is just square root of 2 because I can't do anything with it. And it's as simple as that. I'm done. So I'm going to do another one here. This is 9 and 5 and -1. So -4 plus, I can't combine them because the one's got an I in it, one doesn't. Square root of 9, which is 3. Square root of -1, which is I. And square root of 5, which is square root of 5. Done. This is not a FOIL problem. This is a FOIL problem. This is also a FOIL problem. So maybe we'll circle those. FOIL. This is not FOIL. This is also not FOIL. What this is a -1 getting distributed into there. So then, once I've done that, negative times a negative, negative times a positive, then it's just combined like terms. 8, and then a 6 minus 4 is a 2i. Same thing here. This is a negative 1 getting distributed here. 8 minus 4i minus 5 plus 3i. Combine to get 3. Combine to get negative I. And that's it. Okay? For FOIL, first, outside, inside, last, a negative 10, I times I is I squared. Do the same thing over here. I times I is I squared, so I get 8i squared plus 12i minus 2i minus 3. That's from this and from that. Now I can combine my like terms here. I get negative 3i. Right here, here's the other thing we got to remember, is that I squared equals negative 1. Because if I square that and I square that, I get I squared equals negative 1. So I can replace this with negative 1 and have a negative 8 out here. I can replace this with a negative 1 and have a negative times a negative give me a positive 10 out here. Combine my like terms here like I did before. And then combine the like terms that I have left. 28 minus 3i. Okay? For the next one, negative 8 and a negative 3 is negative 11 plus 10i. Okay? And there's that. There's the simplified problems. The last 3 problems on this page are to write a third-degree polynomial. And what I'm going to have on the test or in the exam is I'm going to have parentheses like this. Okay, and you're going to fill in those parentheses first, then you're going to solve the problem. And if you don't remember, it's x minus a. So whatever this is, x minus negative 2 becomes plus. X minus 4 and x minus negative 4, which becomes plus. This is x minus the square root of 2 and x plus 3. This is x minus 4 and x minus 2i. But if you don't remember, i's and square roots come in pairs. So if I have a negative square root, I got to have x plus square root of 2. If I have a minus 2i, I got to have an x plus 2i, and so on. Okay? Now, why is that significant? Well, let's go back and start doing these steps. If I multiply the opposites, the negative 4x and the positive 4x are always going to cancel each other out. Right? So I'm going to have x squared plus 4x minus 4x cancel each other out, minus 16. And I can just FOIL that from there. If I do that with here, again, I have opposites inside here. They're going to cancel each other out. I get x squared, a minus square root of 2x, and a plus square root of 2x are going to cancel each other out, so I get minus square root of 4. I'll simplify that in a minute. Let's just keep going here. Same thing. I should do these two, because I got opposites. They're going to cancel. So I'm going to have x minus 4 times x squared, a negative 2xi and a positive 2xi cancel. This is minus 4i squared. I could just go solve this. And I'm going to write it in standard form. So I'm going to write it with first, x cubed. And then I'm not going to do minus 16x first. I'm going to do this first just to keep the exponents in order. But it's pretty easy to just FOIL it out. First, outside, inside, last. Write them in standard form. Right here, I know the square root of 4 is 2. So really what I have here is, and it's the same exact thing I did over here, FOIL it out. And I squared again is negative 1, so times that 4 gives me x minus 4 times x squared plus 4. And then FOIL it out like everything else. Becomes fairly monotonous at this point. And there's that page. I got under 10 minutes, so we're doing okay. See you in the next one.